In this video, we will discuss about thermal behavior of polymers. When a polymer is heated to a very high temperature, the polymer properties gets transformed or its material nature is also converted from a solid state to an liquid state. So, with the conversion from a solid state to an liquid state, its property also varies. So, it is of great practical importance to study the variation in the behavior of polymers over a different range of temperatures. So, now we are going to study the variation of elastic modulus E with respect to a temperature. This is the plot which shows the variation of elastic modulus of a polymer with respect to an increase in the temperature. So, in this plot we can see there are 5 regions. The first region is the glassy region, the second region is called leathery region, rubbery region, then rubber flow and liquid. So, over the increase in the temperature, the elastic modulus drops. From the plot we could see the elastic modulus drops, and it also comes from a glassy region, that is, and from a solid state to an liquid state. So, let's see these regions in detail. So, from the graph we could see there are 5 different regions from through which the polymer process over the different temperature range. So, the first region is the glassy region. In the glassy region, that is up to 80 degrees centigrade, a polymer is in the solid state and it looks hard and brittle. So, in this region, the strain is mainly because by the stretching of bonds, and here the polymer behaves like a deformation of a spring. The second region is the leathery region, where the glassy region starts changing slightly. So, in this region there was a rapid drop in the modulus with the increase in temperature, and a reversible sliding becomes a possible one, which causes the small sections, or a chain in the small section to move further, making the neighboring sections also to move. So, this is what happens in the leathery region. That means the brittle nature or the hard nature of the polymer starts breaking. The next third region is the rubbery region. From leathery region or from a solid to what it is going to a rubbery region, that is to a loosey material. So, in this rubbery region we could expect the polymer to behave as an viscoelastic liquid. So, the viscoelastic behavior of the polymer is predominant in the rubbery region than the deformation process. So, as the temperature increases beyond the glass transition temperature Tg, the polymer molecule segments slide reversibly past one another and tend to strengthen out. And fourth and fifth region, that is the rubbery flow and liquid region, where the hardcore polymer completely transforms into a liquid one. So, in this region, the rubbery flow, and in the liquid region, the permanent sliding of the molecules dominate the deformation process. So, the polymer molecule passes one over and another. So, the permanent sliding is possible here, and further on increase of the temperature, the viscosity also decreases, and at a high temperature the polymer is like a liquid. So, that viscous nature of the polymer also ceases out with the increase in temperature, and polymer now looks like a liquid. So, with the variation of the temperature, the polymer also moves from one state to another. So, in each region polymer finds an application, a practical application. So, mostly polymer does not exist in crystalline nature. Very rarely it appears in a in crystalline nature. For a crystalline polymer, this rubbery region is completely absent. That is, The elastic modulus decreases gradually with increasing temperature until the polymer reaches a melting point.